let's take a look at some of the problems that we deal with, just overall the basics of integration. And this is going to include Riemann sums, area accumulation, as well as we'll do a little bit of properties of an integral. So let's take a look at problem number one there. We're given a chart. We're asked to do a midpoint approximation. So if we're going to do a midpoint approximation, it looks like we're going to have three intervals. Okay. And it looks like my intervals are going to be different widths. So we'll have to do them separately. Totally okay. For the first width, we get 3. And then we use the midpoint to get the height. So that would be 7. And then we go from 1 to 5, which would be 4. And we use the midpoint again, which is 5. And then we go from 5 to 9, which has a width of 4. And we'll use the midpoint 6 to get the height there. So I get 21 plus 20 plus 24. Let's see, 41 and 65 looks like what I get for my approximation of the area there. Okay, now let's look at problem number 2. For this one, we are given a graph of f of x. And number 2, ask us to do the area from -4 to 3. Okay, so realize what area that is. That's this area in here we're being asked to calculate. And you can do that as a trapezoid, or you can split it up into triangles and rectangles, whichever one works for you. I'm probably going to do a trapezoid. So the trapezoid area is 1/2, and the height here is 3. And then we add the bases. So the base here is 7, and the base here is 3. 7 plus 3 is 10, times 1/2 gives me 5, then multiply by 3, looks like I've got 15 there. Okay, look at problem number 3 then. You're asked to do the area from 9 to 0. It's not a typo. When your bounds are backwards, you need to flip them, but you will have to put a negative in front of your integral. Okay, so now we're finding the area from 0. So we're finding this trapezoid, and we're finding this semicircle. Now, the semicircle, though, is below the x-axis, so I want you to consider that that has to be subtracted. So I've got this negative in front. Don't forget about it. We'll do the trapezoid. I've got 1/2 times the height, which is 3, and then add the bases. 3 plus 2. Then we'll subtract the semicircle. So the semicircle has a radius of 3. So that's 1/2 for the semi part, pi times 3 squared. And then again, remember, we've got this negative in front. Let's take care of inside the parentheses. I've got 5 times 3 is 15 times 1/2 gives me 15 halves, minus, then I've got 9/2 pi. Now, distribute your negative is simply going to flip those around. 9/2 pi minus 15 halves. So don't forget that negative was a little tricky because the bounds needed to be flipped. We'll want to make sure that we do that as well. Okay, let's keep going with some basic integration here. Now for the next two, we're being told some information. We're told that the integral from from a to b of f of x is 7, and the integral from a to b of g of x is -5. So this is where you're really going to use those properties of the definite integral. For the integral from a to b of 3 f of x minus g of x, I want to split that up. So I'm going to put the 3 in front, and then I'll have f of x dx, and then I want a whole separate integral for g of x dx. Okay, so now let's substitute our values. We know the integral from a to b of f of x is 7. So I've got 3 times 7 minus, and then I've got -5. So that's 21 plus 5, or 26. All right, number 5 then. A little bit tricky. Okay, we are going to split this up, but then I have to use two different approaches. So let's split this one for the integral of 2 dx and then the integral of f of x dx. Now, the integral of 2 dx, you're going to have to do the antiderivative. So the antiderivative of 2 is 2x, but then you've got your bounds from a to b. And your integral from a to b of f of x, you know that's 7. Now put in your bounds. Don't forget, upper bound goes in first. So you've got 2b minus 2a plus 7. All right, and then let's finish up the last two problems here with just some really good antiderivative work. So remember, when you take the antiderivative, you increase the power by 1 and you put it over the new power. So the antiderivative of 6t squared would be 6t to the third divided by the third. See, I increased the power by 1 and I put it over the new power. We'll worry about simplifying here in a moment. Minus 4t, so we'll increase the power by 1, put it over the new power. Plus 3t, and don't forget plus c for your constant that could be there. Now, just simplify a little bit. And there you have your antiderivative. Okay, let's do one more. Now, this one, the last one here, you're going to want to simplify before you take the antiderivative. See, because I can rewrite this integral as 10 to the first times 10 to the what? Oh, not 10. W to the first times W to the 1/2. See, I can make that 10W to the 3/2. Now let's do our powers. Okay, be really careful when you have fractional exponents. So I've got 10, increase the power by 1. So instead of 3/2, that makes it 5/2, puts it over 5/2 plus c. Okay, now be real careful. When you're dividing by a fraction, remember, we flip the second one and we multiply. So this becomes 10 times 2/5, W to the 5/2. So 10 times 2 gives me 20. 20 divided by 5 is 4. So I end up with 4W to the 5/2 plus C. If you want to write that as a radical, you most certainly can. That would be the square root of W to the 5th power. But you can leave it as a rational exponent or fractional exponent if you want. I hope this helps with the properties of integrals, kind of some of the basics, what we were looking for with antiderivative and getting started with the notation. If you have any questions or comments, please leave them below. I would be happy to help in any way that I can. Bye for now.